Hi, we have 10 research projects to show today from the Bentley Applied Research Group. And we think these 10 projects fit together. When you look at them all as a whole, they all address an idea that we could call information intelligibility. Here's an information model that I built some years ago before coming to Bentley. In this video, I take a corner of it and disassemble it piece by piece, just so you can see, although it's a small project, it's already complex and completely full of information everywhere you look. I show it because I show it this way, just to show, look at all, it's just full of pieces, just everywhere. And the question I have about this is, if I give this model to you and ask you to build the building from it, can you make any sense of it? Just simply. Can you see what to build? Is this intelligible, actionable? Well, some people say, in the future we won't need drawings, we'll just model everything. So let's think about that. Imagine we put together the greatest team of modelers ever assembled on Earth. You and I and the others here, we're going to model everything. We'll model everything everywhere in complete detail. We'll convince ourselves that our model is good and complete enough everywhere throughout all of it. And then we'll hand the model over to the builders, and we'll say, here it is. Everything you see everywhere in this model is good enough. Go ahead, build from it. And the builder would say, well, that's fine, but look, I can't make any sense out of it. And then we'll say, well, that's no problem. Just take the model, view it in some viewer, push a clipping plane through it, push and pull the clipping plane and stop it wherever you want. And anywhere you stop and look at it, slice through it, anywhere, what you see where you look at it is going to be reliable and good enough. Nothing's missing. Anywhere you look, everything you see, everything that should be there is there, everywhere. Nothing is omitted. And you can rely on that. And we affirm it. That's our assertion, and we certify it. Well, I actually, having done this enough times, wouldn't make that assertion. I wouldn't stand by that assertion. And, what if something does come up missing somewhere, right? And what if what's missing happens to be something essential? So omission, uncertainty on the one hand, and on the other hand, information overload are two sides of the same coin, indecipherability or unintelligibility. So step back and look at this another way. A model is an information environment. It's an environment of information. And today there is a pervasive lack of effective ways of making sense out of complex information environments like this. Unintelligibility is pervasive throughout this model in several ways, and it's pervasive throughout the industry today. So, how do you make sense out of complex information? How do you do that? The classical way of doing that in AEC, in fact, is the drawing. A drawing is a way of looking that brings intelligibility to complex information. It's a way of looking that makes things understandable, directive, actionable. And what's essential in that we have to take with us into the future is this idea that complex information demands ways of looking at it that make it make sense, that make the information useful. Now, the particular form of drawings can and probably will fade away over time. Right? But what they do remains and will continue to remain indispensable. The need for understanding is permanent, and by no means is that need in decline. On the contrary, the demand for ways of looking that make sense of complexity is on the increase as the methods of sense-making struggle to keep pace with the ever-increasing complexity in information environments. So please consider this in terms of two categories: information and ways of looking at information. In the information category, you have the common information types: models, point clouds, databases, photography of any kind, and others. And in the ways of looking at information category, you have the classic drawings, plus we're searching now for new ways of looking at complex information. And that is the subject of our research, and we believe it's an open innovation space, frontier. To begin with, it seems obvious to us that the two categories have to be brought together. You need to put the ways of looking at information in the information itself. And so our research is interested in three things. Number one, we want to take the common information environment types and combine them together in new ways, in ways that attempt to make each of them more useful. Two, we want to take the ways of looking at information and put those ways of looking in the information itself. And third, we want to seek and discover and invent, if possible, and as necessary, new ways of looking. And if we achieve those three things, or move in that direction, then we're moving toward our goal of intelligible information environments that reveal within themselves, as I said, the ways of looking at them that make them understandable, directive, actionable, useful. And the first step in that direction started last year in 2012, when Bentley introduced into its product line what we call hypermodeling, which in a nutshell is this. You see these markers floating around the building, these little icons? Each one of those indicates that the project's drawing document set, that there's a drawing in the document set representing that location. And if you click on one of those markers, then the system automatically brings the drawing document and aligns it in place in the model. So what you see as you move around and click on these is that you have an information environment that reveals within itself ways of looking at it that make it make sense in specific and useful ways. So here you're able to show someone in this very complex information environment a way of looking at this information that is useful in some specific way that matters, that you're trying to communicate something that matters to someone who needs to see what you're trying to communicate and understand it and act on it. And in this case, you're saying, here's what to build this, And that's a primary communication. And I think we can demonstrate that in this information environment, that communication is more effective than it is when it's communicated strictly in the abstract, in its conventional drawing form. So you're improving the effectiveness of the communication, as well as, at the same time, improving the effectiveness and usefulness of the information environment itself. So here it is in action. You notice it starts at the video, just for demonstration, starts out as a model with drawings aligned in it, and then it fades here and becomes we just swap it out for a point cloud, and it's the same procedure, same effect. Well, is that all there is to do then? Just combine point clouds with models and put drawings in them, call it a day, and head off to the pub? This is, by the way, this is a pub here. We're not done yet, though. There is more to do. There are more information environment types to combine and make use of, and there are more, certainly, new ways of looking yet to be discovered. And that is the subject of our research, so let's take a look at some of those projects. So this project deals with spherical photography, which is an information environment like any other, and so it needs to be combined with the others. So this particular project actually combines spherical photos with models, and also with an Enterprise Bridge EB Asset Information Database, and also with a ProjectWise data store, and also with the very large data store, the Internet. So it combines these all in one unified information environment. We took, on this project, we took spherical photos with our camera. We happen to have a fancy camera, but you could do the same thing with a $50 mirror attachment for your iPhone. We align the photography with a simplified model. The model and the photos, they complement each other, so you don't have to model everything, and neither the photos nor the model has to be perfect. So in this project, we prototyped a couple of methods of aligning those two together. One works like PhotoMatch and does position calculation from a few image model match points, and the other alignment method is more manual, but it gives you real-time visual feedback as you make alignment perfection adjustments manually. Anyway, the photos and the model are then combined with the EB database and the ProjectWise data store, and of course the Internet. And the project also includes search. So you enter search terms and you get the result back visually. Now, notice the possibility of directiveness in this environment. Let me wait for the screen to catch up. It's one thing for someone to walk around in this environment and click on anything they see. It's another thing to reveal some authored directiveness, including, for example, say, a maintenance task list, which in that scenario you would say, okay, go look at these pieces of equipment, observe these conditions, report this information in these forms, and for this app here to walk you through that, showing you the first piece of equipment, what to look at, what to report, where to report it, and then guiding you to walk to the next piece of equipment, showing it to you. Okay, that's what could be called directiveness. And if we did that here, then you could call this a directive environment, an intelligible one. Okay, so let's take that same kind of information environment that includes photography and look at other ways of looking at it. Here, you can discover your project's drawings, similar to the other examples, but in an environment that happens to include photography. So here you see your directive instructions on what to build within an environment that happens to include photos. Okay, this project takes another step and investigates a kind of dynamic clipping. By the way, all of these projects should be thought of not separately, but instead think of how all these ideas can fit together, how they could be used together to help you author intelligibility within complex information, but also help you discover, read, and interpret that intelligibility. So all of these projects are fragments that should be connected together with each other. Here's another project, similar, but this one allows movement into and out of the photo node. At a particular communication node that may include photography, or it may not. If it does, the photo is not a jail. You can include photography where it's useful, and then you can move outside of it wherever the photo isn't useful, or if photos are not available. So also notice in this project the idea of selective clipping. We're cutting a hole in the wall to see things, but we cut too much away. We want to cut the wall, but we want to see the pipes, for example. So we developed a simple control in our prototype that lets you define what gets clipped and what doesn't. So you can author and apply the clipping selectively by type. Here's another example of a transition into and out of a node that includes photography. So here I'm in a model and I click on a marker that happens to include photos. So, okay, when I click on it, my camera starts to move, and as it moves into the position of the communication node. As I arrive there in that position, as I just did, the photo fades in. And in fact, in this particular case, what fades in is a combination of the photo and a design rendering of the building. And of course, then within this, we could invoke some intelligibility, as we've been doing in the other examples. Here again, in this one, selective clipping plus a test of dynamic occlusion. So this would be in situations where instead of using pre-recorded photos or video within which to author intelligibility, you may be viewing intelligibility in live video. So here we tested whether we could detect things in motion. There's Stéphane Coté in motion in the video, and make those things in motion stand out in front of and occlude model elements behind. And we can do the opposite too, by the way, make them invisible. And you'll see, for example, that Stéphane would be able to locate his hand against the pipe inside the wall, which is otherwise invisible, and say, draw a line there on the wall. In this one, we move into full motion video, where the camera itself is in motion. So we put the camera in motion, we walk around with the video camera. We record the video and we detect the motion path relative to the model and the point cloud, actually. And we mark the camera path with those blue lines. So there's one going around in the inside and another one outside the building. And you could use an expensive camera, or you could do the same thing with a $50 attachment to an iPhone, as I mentioned. So anyway, we built this combinant environment out of the video with the camera in motion and the model, and we align them. Once aligned, they stay aligned. And you can click anywhere on the blue paths. And when you click on the path, the camera starts up at the point where you clicked and shows you the video from that point. You can spin around and look at the environment in any direction, because that is panoramic video. And you can advance the video forward and backward, as you see there. And so, of course, your freedom to author and view your ways of looking within this information. And by the way, and I'm not showing, but we have this working with both pre-recorded video, and also the tracking is maintained even in live video. Please look to our blogs for more information on that. Okay, this one is for underground utilities. And this is interactive. It's not pre-recorded. So you would be using your tablet, and with your finger you make a hole in the ground, you drag the hole where you want to. It's interactive. You resize the hole where you want. And you have good perception here. In a natural way, you can understand where the pipes are in the ground, how they relate to things on the surface. Again, of course, this one, like all the others, can and should combine the various ways of looking that we've been exploring in the different projects. So this project actually added one specific way of looking, well, in addition to this virtual excavation. There's a parallel projection plane, which you'll see in just a second. So the parallel projection plane at the top right, which gives you a good view of the depth of what you're looking at in the hole. So again, a way of looking. This one takes point clouds and puts them on iPads, but as you know, point clouds could be 40 gigabytes, so would strain a lot of mobile devices today. So, but we're doing this by using the idea of spherical rendering. You render nodes within the point cloud, and of course the result is very lightweight. It's just an image. You could display any number of such nodes on an iPad, and certainly you could jump into and out of those nodes, as we showed before. And theoretically, when you come outside of one of these image nodes, you could find yourself in a lower resolution sort of sketch environment. Why not? Also, this project shows again the idea of combining images with models and database links and properties. Okay, this one puts augmented reality goggles on a person and augments a live scene with just ordinary drawings. And you can see in that particular type of scenario, tracking is a hard problem. Another aspect of this one is the idea of exploded views. So things in motion. So that's a very important way of looking that helps show not only what to build, but how things are built, how things are assembled. So it goes from the question of what to build to the question of how to build. And both of those kinds of questions, what and how, and their answers need to be authored and revealed within information environments to make intelligible information. And where this project also shows an idea of giving someone sort of guided instructions of here's an arrow pointing to this needs to go here, put it there, and now you've got it. It turns green and so on when it's correct. So there's communicating what to build and how to build, but there's also something else that goes along with it and before it, and that is developing the design ideas to begin with. Special thanks on this project to Professor Mark O'Brien and the University of Kentucky College of Design. Here we took the existing Hypermodel tools that Bentley put out last year, and we asked a question. Instead of vector drawings and vector models, what would happen if we make a hypermodel out of hand-drawn drawings or paintings and models built by hand? So now we're working with, as you can see, we're working in a kind of thought space, where our thoughts and design ideas are informed by our own inspired hand drawings and hand-built models. That's a cardboard sketch model that we converted to a point cloud using a free online service, there are many, that makes point clouds from photos. We used visualsize.com. Then we put a couple of call-out markers in the model in MicroStation, and in the usual way, we made drawing documents with those model views. And quite simply, to those documents, we just attached the hand-drawn drawings after we scanned them, and that's it, nothing more. The rest of this just happens automatically. The hand drawings show up in the point cloud model automatically in place. So now we have the thought process of our own drawings and our own hand-built model informing our thoughts in this space here as we continue our design thinking here, as we design and model within this competent environment that is now composed of our thoughts, and our media, our work, our drawings, our hand-built models. And as we continue adding we'll continue modeling here within this. We're developing our design, our modeling, and we'll be authoring directive ways of looking at this environment as we go that we'll author here, and it will help us understand what we're doing, what we're thinking, what our design is, and ultimately helping us communicate what to build and how to build it as we and others author our communications within this environment. So this project is at its very beginning. It sets up a design space that will evolve through the design process and would be delivered for construction as an intelligible information environment that shows within it what to build and how to build it. Okay, to wrap up then, this is the idea we're after: intelligible information environments. So information environments should show you the ways of looking at them that make them useful and make them make sense. And such environments will be extremely useful in all phases of AEC: design, construction, and operations and maintenance. The two categories of information and ways of looking at information should be brought together. We'll combine information types, we'll put the ways of looking at them in them, we'll discover and invent new ways of looking. This is an innovation frontier that industry very much needs, because this is not enough. Information models need to be decipherable and actionable. And now they are, for the first time, because in 2012, last year, Bentley introduced software that takes the ways of looking at complex information that make it make sense, drawings, and automatically puts those drawings in the model, in place. Now the model reveals within itself the ways of looking at it that make it make sense, that make it understandable, actionable, and affirmative. It's clear now what is affirmed and what isn't. In this case, I affirm that here, everything that should be here is here. You can rely on that. And that's a step forward into the future. But we don't have to go into the future. We can stay where we are. We can keep on delivering drawings in the abstract like this only, using BIM as a modeler that automates drawings like this. Delivering drawings stuck forever in their abstract form and delivering models that are practically indecipherable. Or we can start moving into a future where information and intelligibility are never again thought of as separate things, where the information environments we develop and deliver reveal within themselves the ways of looking at them that make them intelligible, directive, actionable, understandable, in a word, useful. Please visit our Bentley Applied Research blogs and discussion groups. We very much welcome all feedback. Thank you for your time.